Hey gang, welcome to the solutions walkthrough for bonding and drawing structures. If this is your first solution walkthrough, let me just give you a bit of background. When I made jOeCHEM, I did all the videos and all the worksheets, but I always had students, I always had the brave jOeCHEMists either email me or submit survey feedback saying they wanted some supporting video for the worksheet practice, and that's what this is. So if you're here, you may have attempted this worksheet, maybe you're looking for some clarification, maybe you're just looking, to make sure you did everything correctly, or how, wondering how I did it. So without further ado, I'll stop the chit chat and we'll just dive right on in to this worksheet. Okay, so I'm just gonna put this right here, but I'm just gonna go from the beginning, do problem by problem, trying to give as much detail as possible because obviously you have the answers. I'm trying to add a little bit more, give you something extra for watching this video. So, in problem one, we're drawing Lewis structures, right? So I'm going to give you, the formula, the chemical formula, molecular formula, and then you're going to come up with the Lewis structure, right? So, assume you've watched the Lewis dot video, we have a process. So, for number one, we have ammonia. This is for letter A. So, very first thing we're going to do, let's see how many electrons we're working with. So, we know nitrogen brings 5 electrons to the table. We have 3 hydrogens, 1 electron each, gives us a grand total of 3 electrons, right? Because we have 3 times 1 hydrogen. So we are working with a grand total of 8 electrons. Cool. So I think it's easy to see that nitrogen is going to be our central atom here, right? So what we'll do is we'll just go ahead and remember, if we're doing this the foolproof way, we'll give everyone a full octet. So you can see we have 3 hydrogens. We know hydrogen likes 2 electrons, right? It only has that one s shell. It only fits 2. So hydrogen's good, hydrogen's good, hydrogen's good, and we've used 2, 4, and 6. So to give nitrogen a full octet, we give nitrogen a lone pair, and of course we're starting off with a W, starting off easy. You can see 2, 4, 6, 8. We have 8 electrons to work with. Full octet, full octet, full octet because of the 2, 2, 2. And then nitrogen is in control of 2, 4, 6, 8. Bang, good to go. Ammonia, we solved ya with no problem whatsoever. Okay? So, moving right along. Nitrite. So remember, that minus charge is going to come into play. This is B. So again, let's see how many electrons we're working with. Nitrogen brings 5 to the table. We have 2 oxygens. They each bring 6 to the table, so we have 2 oxygens times 6 electrons. That's going to give us 12 electrons total. But remember, we're not done because that would be 17. However, we have that -1 that comes along with this ion. So we have, 1 electron extra. So for a grand total, we are working with 18 electrons, right? Cool. So again, I hope you can see we have 2 oxygens, we have 1 nitrogen. So nitrogen's probably going to be the central atom. So I'm going to put nitrogen in the middle. I'm going to float an oxygen here. I'm going to float an oxygen there. So remember, let's just do the really easy way right off the bat. Let's give everyone a full octet. Okay, so 2, 4, 6, 8. Oxygen's good. 2, 4, 6, 8. Nitrogen's good. 2, 4, 6, 8. Oxygen is also good. Let's consolidate, or let's see how many electrons we used versus how many we have available. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 1, 2, we have 2 extra too many. So what we can do is let's erase a pair from each and make it a shared pair, just like that. 2, 4, 6, 8, 2, 4, 6, 8. 2, 4, 6, 8, 2, 4, 6, 8, full octet, 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 16, 18. Excellent, right? And this is a bit early for the formal charge people. If you haven't watched the video on formal charges, nitrogen comes from the 5th column, fully in control of these. 1, 2, 3, 4, 5. Nitrogen is neutral, that's 5 minus 5. Oxygen here, 1, 2, 3, 4, 5, 6. 6 minus 6 is 0. 1, 2, 3, 4, 5, 6, 7. 6 minus 7 is a minus 1. This oxygen has the minus 1, but even if you're not going to do the formal charge, you have to bracket the structure negative charge up there to signify this is an ion with a minus 1 charge. But I hope, formal charge thing aside, the Lewis structure, not that bad. Moving right along. Alright, C. So for this one, a little bit more straightforward. I almost think these are a slightly different category of Lewis dot structure question, if you will. So this is our good pal ethanol. Okay, so this is almost right along in a row. I'm almost going to do this a little bit differently. I think you can see, we all know carbon likes to have 4 bonds. So this carbon right here is attached to these hydrogens, and that's 3 bonds. And we can see that the 4th bond is going to this carbon right there. So carbon right here. We can see that carbon is attached to 2 hydrogens. And then we can see 1, 2, 3. We need a 4th bond. That's where the oxygen comes into play. That's attached to a hydrogen. And we need to make sure oxygen has a full octet. So 2, 4, 6, and 8. And I would say just verify how you did this after the fact by counting up electrons. So we can see we have 2 carbons. That gives us 8 electrons. I'm going to start just doing some math in my head. We have 6 hydrogens. That's 6 electrons. And then we have the 1 oxygen. And that gives us also 6 electrons for a grand total of 20. Okay? So let's do some quick math. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Boom. Done. And I'm going to keep this up because D is very similar. So if we look at D, it's essentially the same structure. I'll do it in a different color. Same structure, CH3, CH2, and then we have OH2 plus. So again, we have an ion with a total charge. So all of our work above is valid, right? Because the only thing that's different is this oxygen now has 2 hydrogens instead of 1. So instead of 20 electrons, we're going to work with 19. Okay, so the structure is going to remain exactly the same. CH3, CH2. Now we have O, 2 H's. And in fact, right, so one of these lone pairs is just a bond to hydrogen. So you can see we can bracket this. We can signify it as a plus charge. And again, for my formal charge people, if you know formal charge stuff already and you're just watching this video, oxygen likes to come in with 6 electrons. We get that from the periodic table, 6 valence. 1, 2, 3, 4, 5. That's a terrible 5, but that gives us a plus 1. Oxygen bears the plus 1 charge. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And I do apologize. Same amount. Sorry. I wrote that and I knew. I was like, Joe, you said something dumb. We still have 20 electrons, but it's just because we have the formal charge on oxygen giving it the plus 1. Okay? Cool. I probably made it, that's okay. Yeah, so you see how the work was all the same? We got to the answer very quickly. Okay. 2 more Lewis structures. So here we have azide ion. So again, another ion. This is E. So again, we have 5 nitrogens. That gives us 15 electrons. And then we have the minus 1. So grand total of 16 electrons. I've actually seen this particular this structure be asked on a first exam, so maybe it's on your first exam. So the skeletal structure is nitrogen, nitrogen, nitrogen. So we have 16 to work with. Let's just do it super simple, fast way. Give everyone a full octet. Give them 8 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 4 too many. So hopefully this isn't too fast. We have a couple options here, but we can just erase a pair like this. 2, 4, 6, 8, 10, 12, 14, 16, 18. 2 too many. 2, 4, 6, 8, 10, 12, 14, 16. Bing. Bang. Boom. So 2, 4, 6, 8, full octet. 2, 4, 6, 8, full octet. 2, 4, 6, 8, full octet. So we gave everyone a full octet with, our electron constraint. So I'm going to bracket this, give it a -1. And again, for our formal charge people, and if you know resonance, right, we're only drawing one resonance form because we're not quite there with resonance yet. So 2, 4, 5, 6. This is a -1 over here. 1, 2, 3, 4. This is a +1 here. And then 1, 2, 3, 4, 5, 6. -1 here. So everyone has a charge, actually. Okay? And this will be an example we revisit come, when we tackle resonance. But the Lewis structure, that's a valid Lewis structure, no problem at all. All right, so now we have ozone with F. Okay, very similar as far as using the same atom 3 times. So we have 3 oxygens. That brings 6 each to the table. We have 18 electrons to work with. Okay, so oxygen, oxygen, oxygen. Same deal. Let's give everyone a full octet. Bonds. Okay, 2, 4, 6, 8, full octet, 2, 4, 6, 8, full octet, 2, 4, 6, 8. Let's see how many electrons we use total. So this is 8, 10, 12, 14, 16, 18, 20. Up, 2 too many. Much better, okay? And for the formal charge people, we actually have a little bit of this going on. So we're overall neutral, but we actually have 2 things that have charges, but for the Lewis dot structure purpose, this is what we're working with. So I hope by now, gang, as I believe we just finished problem 1, you can see that this stuff isn't that bad. Yeah, that stuff, not that bad. There's a process, there's a procedure. If you ever get, and again, you're gonna get way better at these. You're probably already not doing the full process like I am in this video, which is good. So, next we have we will take this from bond line and put it into our molecular chemical form. So you can see we have 3 hydrogens here, 2 hydrogens here, 3 here. So this is CH3, CH2, CH3. And then over here, we have 1 less hydrogen here, 1 less hydrogen here because we need the extra bond to carbon. So CH3, CH, CH2. This skill, I'm not going to lie to you, it's not super important in no-chem, but at this point in time, someone might ask you to do this, so now we know how to do it. Board's a little dirty, should have cleaned off the eraser. Okay, so then now, we have questions like this. So we're just going to go from this structure to the bond line. So again, CH3, because there are 3 hydrogens here, 2 there, 2 here, and 3 there. And then basically the same, our only difference in the right side of the arrow is that there's only 1 H here. So we have CH3, and then you could even do CH and put a Cl up here if you want to be very explicit about where things are laid out. CH2, CH3. Okay? And then now, just moving along, we have this structure right here, and an arrow going to this structure right here. So the way I would approach this is, again, there's 3 hydrogens here. There's only 1 hydrogen there, so I would do CH, OH, and then CH3. There's a couple ways to represent it, but that's how I'm going to choose to do it. And then here we have CH3, and then I would say you're going to have CO. There's no hydrogens here, and then CH3. That's how I would draw that, okay? And moving right along, here. And again, what we're going to do is we have CH3 right here. I'm going to start doing these in different colors. CH3, just the one hydrogen up here, two hydrogens here. So that means we have CH2. Sorry, CH. I'm following my own advice. CH2. And then over here, we still have the CH3. We actually gain a hydrogen at this point, so that's a CH2. And then we actually have, this is actually commonly denoted as CHO, or this works as well, CH2. You could absolutely do COH, but CHO, that's usually indicative of what this functional group is, which is an aldehyde if we're going to peek into the future. Okay, so let us keep going. So now we're going to do kind of the opposite. I'm going to give you, we were given structures that look like this, and we went the other way. Okay, so very easy, 4 in a row. And then right here we have 4 in a row, but at the second carbon, right, we have that bond to this OH. So that's how that is done right there. Next up, we have this ring, and then we're going to a slightly different form of that ring. This is my first of these videos, gang. I'm going to do a much better job of just splicing up the parts where I'm explaining problems, so you don't have to waste time watching me draw this stuff over and over again. So I apologize for the first rocky solutions video. Okay, so what we're doing here is we just have a complete ring like this, because you can see 2 hydrogens, 2 hydrogens, 2 hydrogens, 2 hydrogens, and I'm just bad at connecting the dots. 2 hydrogens. Over here, it's almost the exact same thing, but instead of having 2 hydrogens here and here, we just have 1, so we actually have a double bond right there. And we'll do so many things with double bonds in OChem 1 and 2. Okay, so again, let me erase this, and we have our final problem. Okay, so we have H3, and you know, we even draw a little bit, yeah, that's okay, we'll do this. CH, CH3, what do we have up top? Another CH3. That goes over to, okay. I made this worksheet a long time ago, and I have glanced at it, but I am not too familiar. There we go. Alright, so to take this from, its structural form to bond line, we just have carbon, carbon, carbon. So CH3, CH3, just the one H right here, and then another CH3, and then over here we have, still the CH3, still the CH3, still the CH3, but instead of a hydrogen there, we have a bromine. Okay, gang, so like I said, these solutions videos will usually be more efficient. This is the first one I've done, so instead of watching me redraw problems, I'll do much better at splicing the video up, just so you see new problem, explanation, cut, new problem, explanation. But I hope you find these helpful, and if you're watching this, that means that you've paid what I hope is what I hope you view as a small amount. So thank you for supporting jOeCHEM, and I hope it's not too much money for you to pay, but I hope this video walkthrough was informative. I hope you understand the worksheet, the underlying worksheet better. Thank you for being a jOeCHEMist. Thank you for liking my videos, hopefully subscribing to my YouTube channel, hopefully telling other potential jOeCHEMists about the website, and I wish you luck on this being the first video, the rest of your organic chemistry journey. And I hope you're gonna go along, I hope you're gonna bring me along for the ride, and hopefully I'll see you all in the next video.